So make sure you've done the activity and converted your heart rate into beats per minute. Okay. And some examples of, make sure that you've come up with some of your own, but some examples of rates that you would see in everyday life are like speed, which is comparing kilometers per hour, or density. In science, you're going to learn about density, and that's going to be, you're going to be measuring the number of grams per centimeter cubed. The cost of gasoline. Okay, the other day when I was driving around, I saw cost of gasoline as $1.35 per 1 liter. Okay, groceries, when I buy apples, lots of times I see apples for $1.99 per 1 pound. Okay, so we're comparing dollars per pound. Okay, a mortgage rate is we have some percentage per year. So every year you're going to pay 3.5%. Okay, so a unit, many of these I've shown you, the ones that examples I gave you are unit rates. Okay, and unit rates are a special rate, and they're very useful in that they allow us to compare a rate or a ratio to 1. And that's often called a conversion rate because that unit rate, when we find a unit rate, is often our multiplier and allows us to do many conversions. So since it's a multiplier, to find any multiplier is the same as finding a unit rate. And a unit rate, to determine the unit rate, we need to divide. And this is a very simple concept, but make sure that you remember it. Okay, so we divide. So if we want to find a multiplier, or in other words, a unit rate, we divide. Okay, that's very important. Is we can always find a unit rate very easily by dividing the rates. So unit rates are really important because they allow us to compare the rates to each other. So when we have two rates that are comparing the same quantities, we're able to compare them much easier as well. So not only do they give us a multiplier or a conversion factor, they also allow us to compare quantities to each other, or rates to each other, in an equivalent way, because we're always comparing them to 1. So when I go shopping, often it's when you're buying groceries, the rates are often given in 100 grams, or it could be a kilogram, could be a pound. Okay, but usually in a standard rate, so that allows us shoppers to be able to compare the rates to see which ones are the better deal. So let's do a couple examples here. So we want to find the unit rate. So we're earning $100 for 9 hours of work. So if I want to find out the unit rate, I'm going to take my $100. I'm going to divide by 9 hours. So there's my rate. But to get the unit rate, I'm just going to divide those two numbers. So I go 100 divided by 9, and that gives us 11.11. So $11.11 per hour. Okay, so make sure that you have that rate still showing. Okay, you need both quantities to make it a rate. Now the unit rates can also go the other way. We could actually divide the other way. So we could also say, I'll do this in a different color. This is equivalent 9 hours for $100. Okay, so we get 0.09 hours per dollar. Okay, for $1 we got to work 0.09 hours. So typing, if I'm typing, I can do 660 words in 10 minutes. That means 660 words every 10 minutes. Okay, now it's useful to know the words per minute. So if I divide, I get 66 words per 1 minute, or words per minute. Okay, and again, we could take the reciprocal of that, and it's still rate. It's the same rate, in fact. Okay, so we're going to use 10 minutes for 660 words. So this is going to give us, and this is not as useful, the minutes per word. Okay, so if I divide those, I get 0.01515. So I'm going to get 0.15, and this is minutes for every word. Okay, so for a long time they used to have this race in Vancouver, from Nanaimo to Vancouver. It's called the Bathtub Race, and it's a 58-kilometer event. I think they still have it, a small version of it now. It used to be really big. Something that used to happen in the summer, something called Sea Fest in Vancouver. So the competitor leaves Nanaimo at 8:10 a.m. and finishes in Vancouver at 9:40 a.m. We want to figure out the number of kilometers per hour. Okay, so we want to compare those 58 kilometers, okay, to the number of hours. So in this case here, from 8:10 to 9:40, that's going to be 1.5 hours. So I'm going to use 1.5 hours. Okay, so to find the unit rate, then we just divide. So 58 divided by 1.5, we're going to get 38.66 repeating. So we're going to round that to 38.67 kilometers per 1 hour. Okay, or kilometers per hour. So if and again, we can flip that rate around and do 1.5 divided by 58, but we rarely express things in hours per kilometer. Okay, but that is still a rate, and it's in fact expresses the same quantities, but in different terms. So for the next one here, 220 kilometers in 2.5 hours, we're going to be driving at 88 kilometers per hour. So 220 kilometers for 2.5 hours, that same rate can be expressed as 88 kilometers for 1 hour, or 88 kilometers per hour. So here we have Alice. She's making orange juice from concentrate. So you can buy these frozen concentrated orange juice, and then you can mix them with water to make regular juice. So she's using 2 cans of concentrate with 7 cans of water. Okay, so what percent concentrate is the juice? So we have to be careful because the juice is the concentrate and the water together. Okay, so this is not a part-to-part ratio, but a part-to-whole. Okay, so we better make sure that we're clear on that. So part to whole. Okay, so we have 2 cans, which is the part that we're looking for. This is a concentrate. And then we're going to have 9 cans of juice when we mix it up. So when we divide those, we get 0.22. Okay, so as a rate, we could write, say, 0.22 cans of concentrate, or 0.22 concentrate per juice, per 1 can of juice. Okay, but we can also convert that to a percentage, or 22% of the concentrate is of the juice is concentrate. Okay, so we're comparing 22 parts concentrate to 100 parts of juice. So how many cans of concentrate per can of water? It's going to be 2 cans of concentrate compared to 7 cans of water. Okay, so we want a unit rate in this case. So we just want to know how much concentrate this is a part-to-part ratio. So we're going to do 2 divided by 7 to get our unit rate, and we get 0.28. We're going to round that to 286. So 0.286 concentrate per 1 can of water. Okay, so there's our unit rate. So Steve Nash, he has a career 3-point percentage of 0.426. So this is a number, this is a unit rate, so 0.426. This is going to be the shots made. every 1 shot taken. Okay, so this is our unit rate. So we want to know how many shots were taken if we had 200 shots made. So we want to know the number of shots taken. Okay, well, this is our unit rate, and we can do this as a unit rate problem. Okay, so we can either divide or multiply by this unit rate. Now, we're not sure, but remember that this proportional equation really makes us understand the direction. So in this case here, that's our multiplier going from bottom to top. Okay, that's our unit rate, which is our multiplier. In this case, we're going to go in the opposite direction, so we want to divide by that unit rate. Okay, so when we divide by that unit rate to get x, we get x is equal to, okay, so 200 divided by our unit rate, we're going to get about 469 shots taken. Okay, we're going to round that. So 469 shots taken. Okay, so that's one way to do it. But we have also been working on using that times and divide strategy. Okay, so we have 200 3-point shots. And this is where the rate is very useful. And if we can keep track of the rates, we can use this times and divide strategies. Okay, so we're going to start with 200 3-point shots made. Okay, so we're going to say 200 shots made. And our ratio is shots made to shots taken. Well, really I want to get rid of the shots made. So what I'm going to do is take that ratio, and for every 1 shot taken, I have 0.426 shots made. And now the reason why I orient it this way, for one thing, it gives us the divide, which we want, but also it allows us to cancel out these units, because the end units we want shots taken. Okay, that's what our answer is. We want to end up with shots taken. So we want to get rid of these units and be left with the shots taken units. Okay, this is called unit analysis, and it follows our times and divide strategy. Times on top, divide on bottom. Notice that to find the solution here, we needed to divide. Notice this naturally then positions the 0.426 in the denominator to divide. So this canceling method is a very useful strategy. In fact, when you get into grade 10 and 11 and 12, when you do lots of unit analysis in math and science, this is a very important strategy to have. So when I cancel those out, I'm going to end up with 200 times 1 divided by 0.426. We end up with 469 approximately shots taken.